give me a thumbs up or something. And yeah. All right. So let's see where we are. So we want to go to schema change, operation generation. Man, this is really slow while I'm compiling. Yeah. All right. Sweet. So the whole thing here is that we have a lot of these kind of operations that come with properties that we're going to validate, and we're going to randomly generate these operations. And there are bugs in this where either we're revealing real problems, or more likely our property checking is not exact or precise enough. And so hopefully this thing will finish compiling soon, and then we'll play the game of whack-a-mole. And yeah, I guess the IDE is doing most of the hard work right now. Yeah, cool. So in principle, we should hopefully see some failures soon. So I can kind of remember where I am. There's some other stuff going on with regards to like turning on and off some features here. So we had these op types, and right now, right, I was trying to make this into a flag, but I had not finished that. And then I've disabled this foreign key constraint and unique constraint thing, which I'm going to want to re-enable, and then see what issues we hit. So another thing I want to do is speed up this process of discovering issues. So maybe instead of stressing this, let's just test it to make sure it seems reasonable, and then we can actually run this stress test against a big cluster after we kind of validate that this is all sort of sane. Okay, so we'll come back. I guess I should make an agenda. The flags here is that some things we know are sort of broken, and by there are kind of issues, and it's okay to hit those in some of the tests, but not in most of the tests, I'd say. And so the idea was that we would explicitly disable them with flags eventually, but first was getting us to a happy place. So we can see this thing is sort of running, and it's issuing, like, it's in verbose logging mode, so it's running things like alter view, drop view, alter table, and just generating random schema changes, which is great. That's what it's set out to do. And with it, it has a set of like expected errors, because it might do things like create constraints that you can't create, or etc. All right, so but then what we can do to make this actually have errors is this, which is going to build and compile this thing and then deploy it to a cluster of cloud nodes, and then run it under this stress thing, which will run it concurrently. And perhaps I should make the test even a little bit shorter. Yeah. All right. So I'm kind of just waiting for errors I know we're going to hit on some level. So I guess I need this to happen. I guess in the meantime, I can think about what I want these flags to look like. My computer's a bit slow because we're compiling. So we have all of these types of operations. We want some sort of like mix of, we want some way to like have flags to indicate what we want the weights to be, or how to override them. And so I was thinking we would have the like default values, and then we would like update with the flags. So I guess I could have something like But I guess another thing to note here is that this pflag library has helpers for array like flags, list like flags that I could use. Okay. Okay. What is that thing? And my computer will hopefully stop freaking out so much when it finishes compiling this. Oh, I guess I know another thing. Seriously, very, very slow. Slice value. Okay, cool. All right, so we're gonna implement this thing, and append makes sense, replace makes sense, and then give slice. Okay. All right. So then I guess I was being a little bit too simplistic with how I wanted this to work. So we have op weights, but really like we want an op weights flag. So we're gonna do something like type op weights flag struct, and it's gonna have weights, which will be an op weight. And really wish the editor were not like dying. And then we'll have override, which is going to be, I guess, a map from op type, and we're gonna make op type a thing if we haven't. I think we have, yeah, to oh wait, I guess. In this way, we could actually like make the string. So this will be like the default, and then yeah, all right. So then this gets simpler. So then we want this to be slice value. Is that the thing that we just said? And then if my IDE were keeping up, which it still is not, this compilation will become incremental at some point. I just had checked out an old branch before, and so wait's just in here. And this instead is now op weights flag. Come on. All right, and then in theory, are we at least at linking? Really, it's Golang that's chugging along, isn't it? All right. Some of this is I made Golang nice, and I did not make Chrome nice, if that makes sense to anybody. Man, okay. Golang is not happy. All right, here's what I'm gonna do. I'm gonna quit Golang. We'll do that. Before it was 20. Right, okay, and that immediately fixed this, which makes some sense. Sorry, the cluster that I wanted was not AJ Werner stress. I'd already created it. It's AJ Werner test. Okay. Cool. And then I wonder if part of the problem here has to do with settings that I had turned off Go modules earlier because I was on an old branch. Maybe, maybe not. Man, these little things. Yeah, sure, that makes sense. This code that I just wrote is not right because editor. Something about modules. Go to modules. Really very slow. Enabled, yeah, that's important. Okay, cool. So that is going to make everything re-index, and that's going to be slow. All right, I think I just can't do this nice thing. I think it makes sense in other contexts, but it's not going to work today. Sure, although that command line is not very interesting. This command line is more interesting. I'm just going to close this one. Golang should hopefully be happier now, and then I'm going to increase my font size for you, which is I think what you want. And then maybe everything's going to work better. Yada, 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 yada. Okay, seems slightly snappier. Sweet. $68, sure, of course not. But it won't matter because nothing is using this. So as soon as this finishes scanning files to index, I guess I can just get that going because none of this is interesting until we have some failures. Sorry for all the waiting around. Should be hopefully pretty fun soon. Imported and not used, of course, because my editor is not happy, and so we'll just put this back as it was. I think this, whatever the streaming thing is using a lot of CPU. Okay, indexing, this is going fast now. Please, please. Okay, yeah, that seems good. I like that. I like this. This all seems good. Yeah, okay. That seems good. Slowly, maybe happening. All right, cool. And so that's running. So this is going to give us some nice outputs. And then we will play whack-a-mole. Okay. All right, cool. So now we are back to wanting this to be op weight flag and slice value, and this should just complain, and then we should do implement methods thing. Yeah. Okay, sweet. So then we want to parse this thing. So op type name to value. Create. So then we want something like parse op type or op weight, and this thing is going to take a string, and this will be a string, and it's going to return to us. Do we get to return an error here? Yeah, we do. Sweet. Okay, and so awesome. All right. So we want to return an op type, an int, and an error. And so we want to say that this is like, let's just say parse op wait parses on a string that looks like op type colon wait. All right, sweet, good enough. So then this is split. Split. There, we could do this with a regex, but this will work fine. Wait, we're gonna do a colon, baseline, split, not equal to, return 0, 0. All right. You know, ad hoc validation is good enough. I mean, all of this is a workload tool. What did we see? What did we see? I'm going to need to zoom out just a little bit. Right. So I have this thing printing a bunch of debug information, which is ad hoc and not amazing. And so these are all the tables. All right. So we see expected errors, failed to receive an error when they were expected in create inverted index if not exist. Okay, and then the question is, why did we not get these errors? So fun. This could be that we have come out of sync with what we now support, because one of those is the like supported features error, I think. Or all right. So this is here. All right, so this is just create index, and then it's what are our various codes. So we're looking for, yeah, so feature not supported is not indexable type. So we must now support inverted indexes on some types that we used to not. Column type is inverted indexable. Okay, yeah, we added more support, I believe. In fact, git log inverted. That's still JSON. All right, I'm gonna do this differently. I'm gonna go to GitHub. This feels like totally one of these cases where let's just do inverted, not by me, and closed. I have a feeling we'll find something. Maybe not. Okay, maybe not. Maybe not. I guess we're gonna have to look up deeper as to why this thing thought it should fail. This thing thinks it should fail. Column type is, yeah, that seems right. So I guess we should look back All right. So ls out dot var tail dash n1 backguard class, and then all right. So what's the failure again? Failed to get create inverted index if not exist on these columns. So we'll need to go find what these columns are. This is a sort of tedious part of this, in that I don't yet have a good workflow to like then just drop into the cluster where this thing fails. In fact, maybe that's a better approach. So and in the meantime, I'm going to do this dash make them workload, because if there are easy to hit errors, it'll just be easier to run them against the local thing and then figure out exactly what's going on. And then at some point I'll get back to the flags thing. Okay, so what was the other one we were expecting to see? Def unique and inverted. No. Len columns. Oh, this is what we support now that we didn't used to support. We did not support multiple column inverted indexes, which I think we do now. And also maybe this. So that's actually worthwhile. Let's go back to here. Inverted. Let's switch to PRs. Allow partitioned. Interesting. Remove experimental multi-column. Yeah, okay, multi-column inverted indexes. Great. Okay, that's exciting. So I think we know now that this is done. And then I anticipate this is no longer a thing. But this one I think still perplexes me. So we'll come back to that. I think one thing that I'm learning is that probably we should have put like more, like right now we accumulate a set of expected codes, but we just don't say why we expect them, like what part of the statement, and that's really hard to debug. So maybe that'll be worth revisiting. I guess right now we have this like set of codes, and that this is just syntactic sugar around that, and it's literally just like, do we expect it? And that may be just too opaque. But it's a good bit of work to like write strings about it. So maybe we don't do that up front. So now we're going to do something like aha, cool. It's like I've done this before. So I don't think I care about this anymore. Run AJ Werner test schema change, except now there's just one node. cool. So this is just going to run it all locally. And then this way, if we hit a more common error, we can just drop into a SQL shell, run the statement, and really poke at it. It's only going to be a problem. Stopping and waiting, starting cockroach version status. Get cockroach version. Right. Wait, why would that fail? I guess maybe. Oh, of course. Because it wants to put, it wants a cockroach to use as its SQL shell. Okay. So a big part of this effort is we've like turned off running this thing because it was flaking. So this is an intern project that initially was kind of swallowing a lot of errors. And so that led to us disabling it kind of on master. And that has, and so entropy sneaks in really fast with this stuff. Also, what is going on with this? Okay. A lot of just sitting around waiting for things to compile. I should have gotten into the like flow of it before starting this, but alas. So, right, for each of these conditions, maybe it would have been valuable to say like what schema doesn't exist and what sequence exists or does not exist to debug this all. There's kind of other work in the integration style test here to like generate backups. But even still, I think parsing failures from here is going to be onerous for a long time until we invest in that. Are we there yet? Are we there yet? Okay. I guess I would like to be able to do things in parallel, but compilation woes. Which is here. Okay, great. So now I can just this thing, and then maybe, hopefully, I'll get something nice. It should just be a big wall of text really soon, in principle. Oh, of course, my problem here is that the cluster is AJ Werner test. But what I really want is local. I could use a variable or something, and I probably should. And its schema change? Fine. Roche put local bin workload. Hey. Okay, cool. And now it goes. And then we do even a little bit more waiting and hoping. And for a while in this project, this was like a really quick way to get results. The problem is as the errors became more rare, this became increasingly sort of useless as an approach. And so the like going to a cluster and running this stress thing is really the only way to get errors out of it. And that may be the case after I fix that may be the case. I am concerned about this whole not indexable type thing, given I don't think we changed that set. Although maybe we allow you to inverted index over multiple columns where only one of these is of that type. And in fact, that would make sense given what we saw. So So maybe what we want to do here is kind of or this. So like an invertible index, it's like if this is equals to non-indexable type or true. Well, okay, wait. This should never become false though. If it's inverted and any of the types are this, then this would be true. And so that seems not like what we saw. I mean, I guess the other thing we can do is we can go back here. So like, what was this? Fail. Okay. So like, what are these various columns? I make no claim that this is an efficient way to debug this. So it's just like, what is this table then? Alter table public. Okay, so there was a rename. So it's 433. Maybe it was renamed. All right, cool. So create table this thing. No. Create table this. Create table as joy. So I guess maybe we should just back up. Say like what are these columns? And I also, the ask is calling. Alter column set not null is not null. That's an array. All right, so we know this one's an array. Alter table. Create table. So int bytes, and then 483. Not a computed column. Where was that? 483. Reg proc. Okay, cool. All right, so one of them is a. Let's play with this. Am I allowed to do this now? Create table foo int primary key j string array k int alter table foo create inverted index foo idx on foo ijk. Okay, that's good to know. We are going to need to know that. but then that works. Okay. So like this is obviously going to be a problem for our validation logic. So we want to be the case that the inverted index columns are the last. Oh, can we have multiple of them? Okay. Column L string. Can we do this? No. Okay, so one inverted column is the last column, otherwise not allowed. All right, so then let's undo some of these things. One, all right, so let's also do with storing. Inverted index do not support stored columns. I'm pretty sure that's fixed. Enter table foo add column m int as I stored. As I stored. Okay. Sweet. So this is just wrong now, but that's cool. So coming back, this thing we need to fix. These are now just not things. I suspect this is right. Okay, so then the deal is like, non-indexable type is, oh, storing. That's not what it meant by storing. What it meant by storing is storing yeah, never mind. That's still a thing. Okay, but this is not a thing. And then this here now needs to be a different structure. So the deal is non-inverted. So I guess the thing we should do is if else. All right. So then inverted index on the last one is of the right type. So it's like if this and I equals len of def dot column minus 1, then this is true. And otherwise, if, all right, I guess we should do it like this. Inverted indexable type. If, all right, so it's like if inverted indexable type or, so it's like if it's an inverted indexable type and it's last, then we're good. Otherwise, if it's not inverted, so then like what's weird is this is the like failure case. So the failure case is it's inverted indexable, but it's not last. I less than len def dot column minus 1. So if this is true, then we got a problem. Or it's not one of these, and I is equal to this. So then parentheses around the fours. All right, good enough. I think, I mean, the thing with this is the test is, does it fail? Like in a different world, we might actually write tests for all of these. But okay, relation does not exist. No, because I canceled that because it was not working for me. So then we want to go back to our make roach prod stress thing and just whack-a-mole continues. I probably should comment. Yeah, no, I did comment. All right. So then on this, I just tend to commit a lot. I have like 17 commits on this branch. If, right. Okay. And probably in another 60 seconds, we'll have our next failure. It really is whack-a-mole. Man, the sun is gonna get me. Okay. Wow. Okay, something failed like immediately. Fun. Unexpected. Create inverted index is not allowed as the last column. Well, wait. Okay, so I clearly screwed something up because that seems right. I guess I should read my code. So we said what? If this is inverted and, oh, sorry. This should say not. Then it isn't on Joy. Well, at least we know we're getting coverage. Very fun. We can have an inverted index on some columns if one, no, it's not this. If the last column is and the 50. Dictionary does not like indexable spelled that way. The word index, it doesn't have anything like it. I think a like forever problem for me has been, is the plural of index in the context of a SQL index indexes or indices? And then the same for like this variable, is it an index? Or if you have plural of these, are they indices? Are they indexes? I mean, I will say that 2 years ago, I was strongly on team indices, and I think I'm a convert. So this is just uploading the stuff to the Google Cloud. One day, maybe I'll set up an environment where I like rsync my code files to a Google Cloud worker. People do it. It's a thing. Or there are other rsync-like things. Okay. So I guess I should think a little bit more deeply about how unhappy I am with these various conditions and the fact that they are not strings that tell me what I'm looking for. I'm kind of upset about it. I wonder what I have the iteration count set to right now. It might be too high. No, 1,000 seems fine. Okay, no failures yet. That's fun. It might be time to turn on one of the features I know is broken. That'll give us a failure really quickly. Man. I'm gonna let this get to some completed run. Okay. So let's make it happen, because this gets a lot more fun when we actually have to add condition checking. Any failure this would find, we'll find. All right, so I feel like there are some clear usability things. The flags for tests that kind of want to be more predictable is a big one. And there's a lot of features we can add here, but being able to like track down what went wrong is going to be kind of an increasingly problematic thing. The way this all is set up on some level is the operation generator just generates stuff, but it like queries the state of the database to figure out what could happen. And in practice, what this does is it enforces correctness over the like various ways it does introspection and how that interacts with the like PG catalog tables and then schema change state. And so this is actually uncovered like a ton of bugs related to PG catalogs exposing things that they shouldn't, or vice versa. And like the more we can come to trust this corpus, the more we can trust refactors and changes to schema changes, because this in some senses is the best kind of catalog of properties that we expect to be upheld. So this like error screening code, it does some pretty wild things. Some of them are really simple, but then the checks get kind of deeper and deeper as we go on, to the point that we're like parsing apart strings, which is kind of crazy. I would say writing some of these has really pushed the bounds of my SQL usage. It's good to practice writing SQL when you work on a SQL database, and it's better to practice writing SQL that tries to understand the structure of the SQL catalog in your SQL database. Something satisfying about it on some level, like checking understanding. So column has single unique constraint. Yeah, this sort of thing. So I think now, I guess given that I just turned on foreign keys, I should look at what these checks are, because I think some of them are wrong. That failed quickly. Cool. Failed to receive. Well, that was a really boring one on some level. Why would we expect this? So we would expect 2B PO1. Man, I also wish that those strings were like nicer. Probably this. No. Well, wait. Why would rename table? Oh, this is another thing we fixed lately, which is great. Eric, the newest intern recently, has fixed this. Okay, this almost is worse though. Okay. I guess one thing we've said with this toolkit is that we're just trying to currently support master. Oh, this is almost terrible. Like, yeah. So we used to not be able to rename things which were dependent on, like, okay, so there's two types of dependencies that come in here. Well, at least. One of them is views and the other is sequences. And for sequences, we just lifted this restriction. So again, fighting some entropy. So let's do this. Default next val s. No, what did I do? Okay, so then we want like select exist, blah blah blah. Except maybe I should go to data grip or something. Maybe my life will be better. So this is going to be public, and oh no, this is going to be foo, and this is going to be public. No. Oh, okay. Well, I guess I can. No, I can't. I'll just do it in place. Public. This is gonna drive me nuts. All right. Database. Wait, don't I have these? All right, fine. Are we happy? Are we not happy? We are happy. Apply. Okay, sweet. Cool. Man, slow. All right. Create table. No. This thing is so darn slow. I really don't get it. Cool, I just want the inner query here. Hopefully it asks me for 1 and 2. And then I should just be able to do like this. Shift enter, control enter. I guess I just want all of them. Yeah, right. Can't I fill this in? Doesn't it prompt me to fill this in? I thought it's like gonna prompt me. Where are my variables? All right, fine. Okay. Oh, I guess I don't really care about just this. I guess I kind of want star. So do we not have forward dependencies anymore? All right. Or maybe these didn't run. Oh, already exists. No, so these must have run. Let's just. Oh, this might be a database thing. Not that. Yeah, cool. Okay. Okay, so then I guess for now we're just gonna say sequence is out because that works now. So that'll help. And this is depended on by type. Depended on. Sequence. All right. now, what's annoying is that this had nothing to do with the foreign key stuff. It's been nice having notifications turned off for like an hour and a half. I don't know the last time that happened. I wonder how long I should go with this. I really haven't made nearly as much progress as I had hoped. This is all just like catch up, not even attacking things I knew were broken. Some of it is that stuff is mad slow. I guess I'll go another half hour or so. This is kind of frustrating because like old things, the point of this workload is to figure out what doesn't work presently. And I guess it sort of assumes that the state is created de novo on the version that it's running. And right now we allow renames with sequences, but not with views. So this kind of captures that. And I guess it's fine. Oh man. I also feel sort of sad about some of these more complex ones that just reach in and pick apart the descriptor. Probably they imply lacking PG catalog or suit to be internal things. So validate foreign key constraints. This one's going to be the subtle one that we have left. Yeah. Okay, quick failure. Rename column. It's the same thing. We expected this, but we just added the sequence claim thing. All right, did I do something wrong? Depended on by type, depended on by details, depended on by name. Column is dependent on, table has dependencies. Okay, this now also same sort of deal. Of course. Where this for dependencies as this, and at least it's quick to find the things. One thing about this process is every time it reveals something that is like clearly wrong, I gain confidence that this tool is gonna like really show its value over time. This thing's a little bit crazy. Sorry, Dan. Didn't mean to turn you on. That was a confusing statement. Anyway. All right. This really is probably not that exciting to watch as I do a lot of waiting. Maybe should have just done this all from a GCE worker. Then the iteration cycle might have been faster. Next time. Okay, so I guess I should go back to this while I'm here. not this. So slow. It happened so fast. Is it going to be the same sort of thing, or are we going to have something more interesting? Unexpected, unimplemented constraint in the middle being added. Try again later. Okay. Interesting. So this is drop constraint and add constraint. I guess I did know this. And this is a foreign key bug. Right. So we have this thing where we, I believe, do not allow dropping and adding the same constraint in the middle of a transaction. That is going to be fun to track. Is that right? Also interesting is that we've created it in this transaction potentially. Drop table if exists. Alter table. So the table existed. This failed. So the table exists. So actually that did not create the table, but then we're adding a constraint and then we're trying to drop the constraint, and this is totally a thing. Okay. So great. So at least now we're on to new things. We knew that foreign key had problems. So how do we detect this? I feel like we might have a state for this, maybe. Okay, so begin. Begin. Alter table foo, add constraint fk foreign key I references to I, which is like a silly constraint. Right. Okay. I find it's like more fun. It's kind of fun to like poke at the database from this way rather than from the code. Okay, so then show tables from CRDB internal is one thing. Something about mutations. Maybe not. Guess not. At least I don't think so. Yeah, no, that's not what that's about. Okay. I could have sworn there was an internal table related to mutations. Did I just miss it? All right, so then instead what we want to look for is okay, constraints is parent table, parent, child, PG constraint. And then there's this whole thing of like, do we mark anything about the state that it's like invalid or validating? Doesn't seem like it. Convalidated. Okay, that seems relevant. But what if I did? Okay. Con namespace, OID, conrel ID. Okay. What if I did not valid? Now what do we see? Yeah, it's a bummer. So I guess there's no easy way to pick that apart. All right, so there's two choices here. We can keep track of whether we did it in the same transaction, or better yet, I think we just want to do this sort of thing. Column not null constraint in mutation. So we're going to do something incredibly similar here. And I wish I had a way to abstract this SQL a little bit better, but I really don't. Because I don't have a way to define functions, which would have been cool. So like foreign key constraint in mutation. And we're going to want like so if we go back to our operation generator, our problem is in add foreign key somewhere here. Add foreign key constraint. No, drop foreign key constraint. Is that right? Drop constraint. Alter table drop constraint. Great, great, great. Okay. Constraint is unique. Well, okay, so we probably have the same thing. It's probably just like constraint is in mutation. So maybe we should find this code here. So let's go to I guess it's just alter. Okay, constraint info, drop constraint, and then here, all right, so if we're adding it and it's unique and we're adding it and it is a check and we're adding it if it's a foreign key, then we're mad. We say this thing, unimplemented. Okay, so that's all constraints. So then it's just accept primary key constraints because those are weird. And so I imagine we don't even support generating them. But all right, so what we want to say is like constraint is in adding mutation. Any dropping one we shouldn't find. So constraint drop index cascade. All right, constraint is adding error equals constraint in validating state, I guess. TX table name constraint name. And then of course if error not equal to 0. All right, so then where was I? So I guess it's just constraint invalidating state. Then we'll do the same thing here. All right, and then what? And then we want to find the constraint mutation, so this is exactly the same. But then we're going to want to filter these. It's like this is exactly the same. I'm sad about this. All right, so let's factor this out then. Fine, yeah. Constraint. All right, instead we want just select exist this and then this is going to end up being painful, but whatever, where constraint detail. Oh man, this gets worse. Hold on. Yike. All right, this is unfortunate. Okay. I guess I need to go into each of these and do some case things. All right. To the SQL shell. Nice. All right. So then it's yeah. Okay, let's make this a little bit nicer with false. The ever opaque false. Okay, so then it's like we're gonna want some sort of case thing and then some name thing. So then it's like select how the cases work again. Nope. CockroachDB SQL function now. I'm now sitting in a dark room. Ugh. Yeah, this thing. Case when blah blah blah. Sweet. All right. So then we want something like select case when mute maybe let's just go straight to constraint and then add con do con, and then we go back to this thing and we say a con foreign key constraint type equals foreign key. Then no, let's just do this because I want to SQL pump this because I'm losing it. At or near from end. Yeah, cool. I'm gonna sign off of this soon, but hopefully you all got the picture of what this somewhat painful task feels like, looks like, is. Yeah, sorry I didn't get through more of this. Till next time.